Fluid is a substance that continually deforms under an applied force. Fluid deformation is caused by the free movement of its molecules. In the case of liquids, molecules are close in proximity, though not as much as in solid molecules, and the arrangement is random. A system that uses fluids to operate is a hydraulic system. Hydraulics is the technology of transmitting force and motion through a confined fluid. In a hydraulic device, power is transmitted by pushing on a confined fluid. The transfer of energy takes place because a volume of fluid is subject to pressure. Click each button on the left to learn more about hydraulic system properties, then click Next to continue. The working medium of the hydraulic system is the hydraulic fluid. Hydraulic fluid is a liquid and can be water or oil. Unlike a gas, liquids are, for all intents and purposes, not compressible. Liquids also flow and conform to complex shapes within the hydraulic system. The hydraulic fluid's ability to flow and its incompressibility allow for the transfer of force. Mechanical force is applied to the hydraulic fluid with a hydraulic pump. The pump converts the mechanical force, or energy, into hydraulic pressure, or energy. There are two categories of hydraulic pumps: positive and non-positive displacement. In non-positive displacement pumps, the volume of liquid delivered for each cycle depends on the resistance offered to flow. Conversely, with a positive displacement pump, a definite volume of liquid is delivered for each cycle of pump operation, regardless of resistance, as long as the capacity of the power unit driving the pump is not exceeded. To harness the hydraulic energy, a hydraulic actuator is needed to convert the hydraulic pressure, or energy, into mechanical energy. There are two common hydraulic actuators in use: hydraulic cylinders and hydraulic motors. Hydraulic cylinders are made from a strong cylinder that contains a moving piston. Hydraulic fluid introduced to a closed cylinder exerts force on the piston, causing it to move. Hydraulic motors are very similar to some hydraulic pumps and convert hydraulic pressure into rotary motion. To control the hydraulic system, various types of valves are used to regulate the flow and pressure of the hydraulic fluid within the system. They can be manually or electrically operated. Some control system pressure, such as pressure relief valves, while others divert fluid pressure to hydraulic actuators. The hydraulic system must have a reservoir to store a surplus volume of hydraulic fluid to allow for thermal expansion and the displacement of fluid to actuators. Also, there are high and low pressure hoses and lines to conduct the hydraulic fluid between the system components. Pascal's law is the foundation for hydraulic principles. The law states that pressure exerted anywhere on a confined fluid is transmitted unchanged in all directions throughout the fluid, acting upon all the interior surfaces of the container at right angles equally upon equal areas. There are three main variables that are interrelated within hydraulic systems. These variables are force, pressure, and area. If any two of the three variables are known, the missing variable can easily be determined. Click each variable to learn more, then click Next to continue. Force refers to the energy exerted upon the fluid and is measured in newtons, or N, or pounds. To determine force, multiply the pressure by the surface area. Pressure refers to the amount of force applied to or by a fluid for a given surface area and is typically measured in kilopascals, or kPa, or pounds per square inch. To determine pressure, divide the amount of force by the surface area. Area is the dimension of a surface that is pushing on or being pushed by the hydraulic fluid. Surface area is typically measured in square centimeters or square inches. To determine area, divide the amount of force by the amount of pressure. Click the buttons to the left to learn more about hydraulic principles. Additional information is available within each tab. When finished, click Next to continue. In a closed hydraulic system, any input force results in pressure. The magnitude of the output force depends on the surface area where the pressure is applied. Input force is typically applied to the hydraulic fluid through a hydraulic pump. The amount of output force is determined by multiplying the surface area of the output piston by the hydraulic system pressure. Hydraulic system pressure is a product of three things, which are the ability of the system to contain the pressure, the surface area of the hydraulic pump element or piston, and the amount of force applied to the pump element or piston. The hydraulic pressure is equal at all points within the same hydraulic circuit. The surface area of the piston or pumping element within the hydraulic pump determines the resulting pressure for a given amount of force. The surface area of the piston within the hydraulic actuator compared to the hydraulic pump defines the multiplication factor. Equal surface areas result in no multiplication of force, whereas a larger surface area at the hydraulic actuator results in force multiplication. Hydraulic fluid is displaced or moved by the hydraulic pump. This volume of fluid will displace an equal volume within the hydraulic actuator. If both the pump and actuator have the same surface area, then the stroke or distance the pistons move will be equal. When there is force multiplication due to different surface areas, the larger surface area of the hydraulic actuator will cause the actuator piston to move a correspondingly shorter distance than the pump piston. A hydraulic system only transmits the energy, force, and motion that it receives. Energy is not created within a hydraulic system. However, motion may be changed into force, or force may be changed into motion.